Okay, so here's what we did yesterday, right? This was yesterday, so 11.8, great. Be sure you know how to do the work. And then 11, isn't this? Oh, what? What? Huh, weird. We didn't go over that. Just a minute. Oh, no, no, no. Okay, sorry. I was on the wrong section. I'm okay. I think we're okay. Yeah, okay. Sorry about that. Thank you, Andrew. Keep me straight. No, no, no. We know. Okay, I know where I am. No, actually, yeah, it's everything's turning into a blur, to be honest. But let's go ahead and we'll just do this and hope for the best. So f of x is equal to x squared over x to the fourth plus 16. There we go. Oh, you can't see it, but I will write. I will put it up here. Sorry about that little glitch with my brain. Well, I don't know. Maybe it was something else. But let me find. Just a sec. This is going to bother me if I don't do this. There. Okay. Now it's full screen. No, everything's good. Everything's good. Yeah, we're in the right section. I don't know what I was doing. Okay, so we want to write this as a power series, and you know what to do, don't you, Andrew? You are always focused on this as the geometric power series. This is sort of the template. You want to shove it into this. So this is going to be n equals 0 to, 1, yeah, 0, yeah, that's x to the n. There it is. So that's sort of the template. We want to get this to look like this. It doesn't. And so what is it that's bothersome to you, Andrew? Tell me what we're going to do first, and then I'll do the rest for you. Don't worry. So what's the big deal here? What's wrong with this? Yeah, let's get rid of the x squared on top. And actually, the x squared on top is pretty easy to get rid of because you can just move it out of the way. Just push it out of the way. Here's how I'll do that. I'll write it like this. Put the x squared down here, and then multiply by 1 over 16 plus x to the fourth. I've done a second thing, and that's to rearrange the bottom. So yeah, so we got rid of the x to the x second. I'll let you off the hook now. So thanks. So the x to the second, just ignore it for now. It's not going to bother you over here. The next thing that is a little bit annoying about this is that 16. Notice that on my little template, I'd like to have 1. Like, it's sort of the way that you want to think of this little template is that everything has to look like this except for this piece. That's the only thing that you're allowed to change. Everything else, it should be 1 over 1 minus whatever. Like, you could put your name here and everything would be okay. You could put a smiley face here. I don't care what goes there because whatever goes there is going to go here. Okay, so let's do this. I don't like the 16 though, so that's my next job. So here's how I'm going to do that, is I'm going to factor out 1/16. How do you do that, you might say? Well, here's how I do it. There we go. So it might take you a minute to realize, wait, that's the same as, yes, it is. Multiply 16 times 1, you get 16. Multiply 16 times this, you get x to the fourth. All right, now we're doing well because we're almost there. So I got to keep what I'm thinking about up there in the top corner. So the next step is to just rewrite this with a minus. Once I have a minus, I'm good. So let's do this. So this is going to be x squared over 16 just to make it look clean. And you know this trick. There we go. Thank you. Yeah, thank you. There. Yeah, so here, get this caffeine flowing. So anyway, yeah, so that's good. So now I'm happy. Look at this. I have exactly what I was hoping for. The only difference between these two is that instead of x up here, I have that thing. But that thing isn't going to bother me too much. I'm just going to basically replace the x there with this. So let's do that. And then I'll be done. So this is going to be x squared over 16 times this sum n equals 0 to infinity of negative x to the fourth over 16 to the n. Now that looks ugly. So let's just make this look a little bit prettier. So here's the goal, and I'm not going to go as far as the book does. Well, I will eventually, because this is a back of the book problem, isn't it? So you can look up the answer, and you might say, mine doesn't look like that. It's fine. But here's what I'll show you, that the very minimum, the minimum that you need to do when you do this on the quiz today and on the test is to do this. You want to get the x by itself and all the coefficients by themselves. So here's what I would suggest. Take this summation and write it like this: -1 to the n times x to the 4n over 16 to the n. Okay, so there's the bare minimum to make me happy, but this still doesn't make the book happy, does it? Because that's not what the book has, does it? It's probably different. In fact, let me try to guess what the book has. The book probably moves this stuff over here. So let's do that. I'll do it slowly so that it's obvious, but I'm not going to write everything again because I'm lazy. So let's copy and paste. Come on. Okay, it's not pasting. Let's try again. Just duplicate. Okay, so there it is. Probably would have been quicker just to rewrite. So that's this stuff times x squared over 16. So you might say, wait, how can you move that in there? Well, this is a summation. It's like 1 plus x squared. And you've got something times a big summation. Using the distributive law, you can multiply this by each term individually, which is what we've done here. And now we can do a little bit more algebra to make it look like the back of the book. And then if this still doesn't look like the back of the book, let me know, and I will make it look like the back of the book. So here we have x to the 4n plus 2, because you're just going to combine those two exponents, and then this is going to be 16 to the n plus 1. So this makes me happy. It might not make the book happy. So is this what the book has, or you want me to make it even more different? I don't know. Well, Andrew's the one who cares the most about this problem, right? So Andrew, how do you feel about this? This one is happy for you? Very good. Okay. Anything else about this one? Number 7. So here, I'll label this so that we remember. That was number 7. 7 look okay? Yeah, Maggie? Oh, thank you. I completely forgot to do it. You want the interval of convergence. Okay, so let's see if we can put that together. So up here, so looking at our template, this is sort of the standard up here. The template would be this, that x is between 1 and negative 1 to 1. So that's what we're working with. So what did we replace x with? It looks to me like the x, whoops, this thing ended up where x was. And so we'll just make that change. And you know the drill is the negative, it's not going to, it's a hassle to deal with. So let's leave it out of the whole thing. So here, this is this. So that means x to the 4th is between 16 and negative 16. And then here we have this same issue. So let's just, I'll verbally mention it. Welcome, Karen. I'll verbally just mention this, but don't worry. I mean, we can wave our hands a bit, but technically x to the 4th is between 0 and 16, because x to the 4th can never be negative because we're dealing with real numbers here. So x to the 4th being between 0 and 16 means that the 4th root of x to the 4th is between 0 and 2. However, when you do the 4th root of x to the 4th, you get the absolute value of x. And so that forces us to consider negative numbers again. And so this ends up being from -2 to 2. So technically, there's a little bit that goes into that. But I'm okay with you just saying, hey, we're going to do the 4th root. And I mean, technically, the 4th root of -16 is not -2. But this will be what you end up with. So, but that's it. Yeah, this is the interval that we care about. That one. So thanks for reminding me that I didn't finish my problem. Anything else that we need to look at, either from 7 or from the others? Now that I'm on the right page, so sorry about that little glitch at the beginning. Yeah, what do you think, Eli? Yeah, let's take a peek. Number 9. That looks like fun, doesn't it? Okay, let's take a peek. Number 9. And let me just copy this stuff. Hold on a sec. Since this stuff up here, come on, duplicate. Just pull this down. There we go. That stuff, that's going to be the template that we work with. That's sort of I want to get my stuff to fit into this thing there. So we'll go over there in a sec. But right now we're going to start with number 9, x minus 1 over x plus 2. So without belaboring this, let's just go ahead and say that the x minus 1 is problematic. So I'm going to move that outside. And then I'm going to do this 1 over 2 plus x. So there's the first step that I would do. There's probably other ways to do this, but let's just go with this. And then this thing will be x minus 1 times 1/2 times 1 over 1 minus x over 2. There we go. So you can double check that everything is still the same here. So I factored out a 2. And when you factor a 2 out of x, you get x over 2 times 2 is just x. So that's where that came from. Oh, always forgetting my negative. And then I've got my double negative to make it into a plus. So far, so good, probably. And then from here, now we can refer to this template over here. And so this thing, let's see if I can get this to aim properly. X minus 1 over 2 times the sum of, let's see, give me a sec here, negative x over 2. I did a pretty good job. There we go. Okay, let me clean this up a little bit, and then we're going to have to talk about that x minus 1, because that's the problem, isn't it? But we could, before we go on, we could just do this, that x, and I'm going to leave off the negative, x over 2 has to be between 1 and negative 1, and so the interval of convergence is from negative 2 to 2, just so you have that. Okay, so let's continue with this thing. So this thing will be the sum Give me a sec here. Hold on a minute, that's not going to work. All right, I'm thinking ahead and trying to get it to be as simple as possible for us. I'll leave the 1/2 there for now. So it's the x minus 1 that's the problem. Okay, so let's see if we can work this out. So there's a little bit of algebra that needs to be done. That's all I'm sort of pointing out here, is we're going to have negative 1 over 2 to the n. This is going to be x to the n plus 1 minus x to the n. So this is going to feel a little bit familiar. Let's write out a few terms of this. So we have 1/2 times, let's see, we have negative 1, no. So start with n equals 0, and you get 1 times x minus 1, and then plus negative 1/2 times x squared minus x. So it's possible to do this without writing all this out, but I think that seeing it written out like this will help to see what's happening. And then this is going to be negative 1/2 to the second times x to the third minus x squared. And you can probably guess what's about to happen, but I'll write it out. X to the fourth minus x cubed, negative 1/2 to the fourth, x to the fifth minus x to the fourth, negative 1/2 to the fifth, x to the sixth minus x to the fifth. How many is he going to do? Yeah, I think that's enough, just to see what's happening here. So, like I said, I think we could have probably dealt with this in this form. Actually, yeah. Now that I think of it, here, let's do this. Let's save this. I'm not going to erase it. Let's move it down so that we can. Yeah. Let's go back up here. So I'm just trying to do this in the most understandable way so that you're not losing your mind. So here, let's do it this way. So let's start with this. And we'll separate this into two summations. So I've got 1/2 n equals 0 to infinity of -1/2 to the n x to the n plus 1 minus this sum of x to the n. Oops, sorry. I forgot all my 1/2s. 1/2 -1/2 to the n x to the n. Okay, so you're using the distributive law, if you will, and the associative law. So I just want to take all of the x to the n plus 1s and lump them together, and then all the x to the n's and put them over there. Okay, now let's deal with one of these. Which one do we want to deal with? Let's deal with this one right here. Notice that this n plus 1, that's a big problem, at least for me, to be able to add these things together. And so what I could do is I could just re-index this. Now, by re-index, what I mean is notice that when n equals 0, you have x to the first. When n equals 1, you have x to the second, and so on. And so instead of using that index, I could do it this. N goes from 1 to infinity. And then we'll just do this. That this is the same expression. So when n equals 0, you get 1/2 to the 0 times x to the first. Down here, when n equals 1, 1/2 to the 0, x to the first. So basically all I've done is I've taken these n's and I've subtracted 1 from all of them. So that here, instead of having n equals 0, I have n equals 1. Here, instead of having n, I have n minus 1. Here, n plus 1 becomes n. So this one is probably the most problematic, but remember, if you do n minus 1 equals 0, then n has to equal 1. So just shifting the whole focus, just shifting the index is basically all that is. Yeah, so I think this is easier than writing it all out. And then this thing is just going to be here, -1/2 to the x to the n. Sorry about that. Okay, now we can recombine these, except for the very first one over here. So we're going to have to set that one aside just a sec. So this is going to be, let's see, the sum where n goes from 1 to infinity of 1/2 times -1/2 to the n minus 1 minus -1/2 to the n, x to, to the n. All of this times x to the n. But that ignored the n equals 0, so let's put the n equals 0 in there. That's 1/2 times, I guess, 1. So there. So this, I'm sure that I could combine this a little bit further. I know those can be combined, but I'm scared of doing that because that's just going to be more algebra. But you can see that what we're doing here, and I'm not sure if this is what the back of the book has. Was this number 9? Yeah, it's a back of the book thing. I don't have my back of the book with me because I only have chapter 11 here. But if this isn't the back of the book, it's equivalent to the back of the book. It's honestly, I would probably make it even prettier, but like by combining those two 1/2s somehow. But I'm not going to mess with it right now, if that's all right. Yeah, let's move on. This is a complicated one. Oh, we did the interval, didn't we? Yeah, we did it up there. Whew. Yeah, so basically there's a bunch of algebra that needs to be done. So I know it's probably not the most satisfying, Eli, but how far am I away from the back of the book? Okay, so, but the back of the book has like x to the n, or maybe x to the n plus 1. But whatever it is, I mean, I've got it in a form where I have some coefficient times x to the n. So that should make the back of the book happy. Oh, and this -1/2 is outside the summation. It's over here somewhere. So yeah, that's not the most satisfying. But yeah, this is all algebra. Yeah, it's all a bunch of algebra. It's just uncomfortable because you're dealing with these summations. By the way, what I was going to do down here, you could have done as well, and you would have noticed that you could combine the this with this, and then combine the x squared. Kind of feels like a telescoping series where you're combining different terms and then rewriting the summation. So that's another way you could go about it, is if that makes more sense. Like the very first bit, you would do 1x plus, yeah, plus 1/2 x, so that would be 3/2 x. And then the x squareds, there would be 1/2 x minus 1/4, so it's minus 3/4 x squared, I think. Yeah, if I've done my arithmetic correctly. But you could try to figure it out that way. It looks like we're always going to end up with 3 over a power of 2, possibly. I don't know. I don't want to commit to that, but that's what it's looking like. So there's that. Well, let's go ahead and do the quiz. I had the quiz literally, it was in my office in a stack. I know I'm super negligent today, but I had it. I was going to go next door because we have 2 people here who skip this on every Tuesday. I don't know if you figured that one out yet because they have another class they do. I was going to go into that class and give them their quiz on the way over here. And I forgot to do that, and I forgot to bring the quiz because I had it all ready. But I have it here, though, and so you can still do it even though I don't have it with me. Here, I will rewrite. Basically, it's 2 problems. They're easier, though, than the one that Eli wanted me to do. So I'll write the second one so that it's up here near the first one so that you can do them both. 2x over, so you can do these on your own. And, well, I'll tell you at the end after we do this how I'm doing grading. I did give you all hundreds for the quiz yesterday because you assured me, right, that you did get 100 on that quiz. So here are the 2. Find the series, give the interval of convergence for these 2. They're a little easier than the one that we just did. Considerably easier, I think. Okay, let's do this. Some of you look like you're finished. If you're still working, try to finish up. And then we'll go over this in just a minute. X over x cubed. All right, let's see how we're doing. Hopefully you're either done with the first one or mostly done with the second one or whatever. Let's just do this. A little bit less glare. Okay, so let's see where we are. Here's mine. So I'm guessing that on the first one you did something like this. You factor out the 3, you've got 1 over 1 minus this thing squared, so that you get it into that sort of form, into that template, this thing that we want to get things to fit into so it looks like a geometric series. Then you can just say, okay, this is the R, the ratio, the common ratio, the R. So that goes here. And then the 3 is going along for the ride. And then there's just simplifying that. And so I just rewrote it slightly. I moved the 3 inside here, wrote it as -1 to the n, x to the 2n. So you're wondering, did I get it right? Well, do you have a -1 to the n somewhere? Good job. Do you have a 3 either here or over there? I don't care if it's inside or outside the summation. You're doing great. And then you have x to the 2n. If you've got those 3 things, you got it right. Good job. If you didn't, fix yours. You still need the interval. I know you're looking for that. So that's up here. And here again, I kind of just glossed over the fact that there's a couple of steps in between the top and the bottom. So we're not doing the square root of both sides of this. It's actually that x squared is between 0 and 1. And then when you do the square root of x squared, you get the absolute value of x, blah, 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 blah. But it's fine as long as we just write it like that. You're good. So if you have this, so here's if you got both of those, that and something that looks like this, that has those 3 pieces. It should have a 3, it should have a -1 to the n, it should have an x to the 2n, or at the very least, I probably would be happy with x squared to the n power, although it looks ugly to me. So, all right, any questions about the first one? Number 1, okay, let's take a look at 2. 2 was fun. It was not that hard, though. It's not as bad as the ones on the homework, was it? So here, this is probably your first move. Might have taken you 2 steps to get to here, but whatever. So you get the 2x, pull that out. And then this 8 came from the fact that I don't like an 8 here. So I'm going to factor out 8, and when I do that, I get x cubed over 8, and then I have to do the minus a negative thing. So you probably have parentheses here. That look all right? It's not too bad. And then once you have this, the rest of it is pretty straightforward because you know what to do with this. This is going in the place of the R, the common ratio, with your geometric series formula. So this thing looks like that. And then, oh, and I canceled the 2, just so you know. And then I moved things around. I wanted to move, so let's see, that's that. I wanted to move the, let's see, let me explain where things went. So this is x to the 3n, and then I've got an additional x. So I kind of skipped a step, but I think you can handle it. X to the 3n from up here. You have an additional x from there. So it's x to the 3n plus 1. And then here, this 8 to the n, that's fine. -1 to the n, and I've got a 4. So here's what you need to make yourself feel good about your 100%, is you need to have a -1 to the n somewhere. You have to have a 4 in the denominator, either here or outside. You have to have an 8 to the n somewhere. And if you want to write this as -1/8 to the n, I would be happy with that as well. You have to have x to the 3n plus 1. Put it all together, move that x inside. So that, I don't care where the 4 goes, it can go out there, but the x should all be together in one grouping, one happy family here. We have yet to deal with the interval, but that's coming. So there's that. Now let's do the interval. You know the drill. You start with this. X cubed over 8 has to be between -1 and 1. This one is more straightforward. Multiply everything by 8, then do the cube root, because the cube root of a negative number is negative, so everything's good there. So the cube root of 8 is 2. Cube root of -8 is -2. So did you get 100? If you didn't, make it 100 by writing those two. Well, something like this and something like this. By the way, one last thing about this is that it bothered me a little bit that I had a 2 to the second and a 2 to the third. 8 is 2 to the third. So I thought, I could combine all that. This is unnecessary, but it would be kind of cool if you did this. So I just combined the 8, which is 2 to the 3n, with the 4, which is 2 to the second. So once again, that's kind of overkill, unnecessary, but it's kind of fun. But you don't have to. In fact, on a test, you might not want to get too fancy, because fanciness is where you make mistakes, right? When you get fancy, you start making mistakes. Don't do it. Okay, sorry. It's a long day. All right, let's move on. We're doing this. Here we are, Power Series yet again. This is day 3 of Power Series. This is the last day. Trust me, the last day. Yeah, tomorrow. Yeah, what do you think, Hayden? Yeah, it's still 11.9. It should be. Does it say in the homework? Okay, since I messed up, I didn't mess up. I had the right assignment. I just messed up with when I was thinking about where I was. Yeah, let's just double check. Let's see. Why does it say due Tuesday? Oh, today is Tuesday. That's why. Okay. Okay. This is April 6th. Oh, today's tax day. Everyone did their taxes? It was a very taxing day, wasn't it? Okay. So, yeah, so due Wednesday. Yeah, it's still 11.9. This is the last bit of 11.9, and then we move on to 11.10, and that will be due in 2020. So you're gonna have to go find a time machine. No, I'm just kidding. I'll fix that. It's just because I copied and pasted all of the homeworks. I realized, oh, I've already had these from another time 5 years ago. Nothing changes in calculus. That's why it boggles my mind that they come out with like new additions to these books. Well, nowadays, no one uses textbooks anyway. Okay, so Power Series. You might wonder, have we not done everything there is to do with Power Series? There's one more thing. One more thing, and that is that we want to be able to come up with a Power Series representation, searching for in just a minute, Power Series representation for all sorts of functions, including things like this. So I know we did this one the other day. I think it was the last thing we did yesterday, but I just want to remind you of the joy that we had in doing the arctangent. So the arctangent is the what is it? The derivative of arctangent is 1 over 1 plus x squared. So because of that, you know that arctan of x is equal to the integral of 1 over 1 plus x squared. So this gives us a way of coming up with power series of functions that are related to other functions that we already know the power series for. So you can do the antiderivative as long as you're careful. I'm going to put a plus c here to remind us we have to think about that. And I know we already did this yesterday, but we're doing it again just to remind you, because we have one here that we're going to do in just a minute that is related to this. So arctan is this, and so we're going to do, let's see, oh, I know. Sorry, I have to think through for a minute. We're going to do this. Yeah, this is going to bother me. Every time I make a mistake in PowerPoint, it's a pain to have to erase. So I'm going to go over here and do this here, because it's a lot easier in this. Here we go. Okay. So what did we have? We had arctan, which is the integral of 1 over 1 plus x squared, plus some constant of integration that we'll deal with. Don't worry. We're not going to ignore it. And so this is going to equal this, 1 over 1 minus negative x squared. So once you have an expression that you think you could use, turn into a power series, we can just go ahead and do this. Let's put the plus c here just to remind ourselves that we're going to have to deal with that. And then here, of course, and I know we did this yesterday, but let's just do it again. This is something that is an easy power series. So this will be negative 1 to the n times x to the 2n. So I kind of, did this relatively quickly, but we did this yesterday. So you do negative x squared to the n. So I've just separated out the negative part, and then the x squared to the n is just x to the 2n. So hopefully that doesn't bother you. And now we can do the antiderivative. I forget, now it's all coming back to me, but I forget who I asked, but someone here did an expert job of doing the antiderivative of this and got this. Negative 1 to the n times x to the 2n plus 1 over 2n plus 1. So just something that you do the power rule, add 1 to the power, right? 2n plus 1, divide by the power. We're good? Okay, so here's the thing about the c. Since I did an indefinite integral, I have to deal with the c. But I already know that I want this to equal arctangent of x. And so let's just pull that down here. Whoops, not that, this. Just give me a sec. There we go. Now it's down here. And so if this is true, then it will be true for every value of x. We could pick a value of x like x equals 1 or x equals 3 or whatever number. Sorry, I had to think for a minute if it was in the domain. But you could do it for any value of x you like, but I want to pick a very special value of x, and that is 0. So always pick something that will be nice and easy for you. So let's do the arctan of 0, and that would equal the sum, where n goes from 0 to infinity, of negative 1 to the n times 0 to the 2n plus 1 over 2n plus 1 plus c. So this will allow us to figure out what the constant of integration is, because those all have to match up. Fortunately for us, 0 to the 2n plus 1 is 0, no matter what n is. And so we're just going to write this like this. Arctan of 0 is equal to the constant. And we all know the arctangent of 0, but if we don't, we have calculators. So c equals 0. So there's my arctangent. The only thing I haven't dealt with is the interval of convergence. So let's do that. The interval of convergence says that, where are we? Where is the thing that we're doing here? X squared, right? So x squared has to be between negative 1 and 1, comes from this here. There it is. So that means that this is good for anything between negative 1 and 1. Did I just violate that? Hold on a sec. Oh, yeah, no, I get it now. Sorry, it took me a minute to think through this. Okay. No, I'm good. I'm good. So the one thing, so this is the interval of convergence, but here, because we did this antiderivative, this thing actually converges for more than that. In particular, we do have to worry about the endpoints, and in particular, it's the right endpoint. So when x equals 1, x equals negative 1, you diverge, by the way. You can check if you don't believe me. But let's check x equals 1. And so this is because of the antiderivative. So whenever you do antiderivatives, you're going to want to check the endpoints. So don't worry about the x equals negative 1, because I'll just tell you that that one diverges. But let's do x equals 1. Let's get rid of that c, because we know c is 0. There we go. So let's do x equals 1. So I know we're going back to where we have to check endpoints, but it's worth it. Negative 1 to the n times 1 over 2n plus 1. What kind of series is that? Does it converge? Does it diverge? Take a minute, see if you can figure it out. Do I even care about my attendance today? I don't know. I'll do it. Okay, so yeah, figure out if that thing converges while I pull up my attendance here. Calculus, good job. All right. All right, so Ryan, you know about this kind of series. What kind of series is this? No, but you see the, yes, it's alternating. Alternating, so you see the plus and minus one. Anytime we have an alternating series, we should be suspicious that maybe this thing will converge. So remember, we're just focusing on a single point, x equals 1. It's like the olden days being last week, where we just focused on this. You can use the ratio test, the root test, or the alternating series test, which is going to be easy for this one. So let's use the alternating series test for this. Lewis, you know about the alternating series test, don't you? What do you have to do when you do the alternating series test? You what? Yeah, get rid of that, right? And then what happens here? Get rid of the negative 1. Okay. And then what? And then you're worried about what's... Yeah, there it is. Do a limit. Very good. So do the limit as n approaches infinity. I suppose that we should also ask the question, is this decreasing? Is this positive? Yes, it is. Yes, it is. It is decreasing, blah, blah, blah. Let's do the limit. So you can do the limit. I know it's been a while, a whole week since we did alternating series test. So it's all coming back though. Caleb, what is the limit as n approaches infinity of that thing? It is 0. And so because this is 0, this thing converges. This thing converges. Converge. Why did this not? There we go. My Apple Pencil needs a new nib, maybe. But whatever. So it converges. So that converges at that side. So this is now the interval of convergence, interestingly. So this thing converges for both ends, or no, for the right endpoint, which is important if you're trying to approximate pi, but not that important, I guess. Okay, so there's that. Okay, so the other one, the second one that I wanted to take a look at was this. Natural log of x minus 1. I want to find a power series representation for the natural log of x minus 1. Well, yeah, what in the world are we going to do about that? So let's see if we can. So here's what I'd like you to think about. Is this related in any way to this? Because that's sort of the gold standard. Like here, where is it? Where's my arctangent? Where'd the arctangent? Oh, it got moved. Anyway, arctangent is the antiderivative of this thing. And that looks like 1 over 1 minus x. What about natural log of x minus 1? What does that look like? I mean, can you relate those two to one another? Yeah, what do you think, Michael? Yeah, the integral, right? Let's do it. Is this the integral of 1 over 1 minus, or x minus 1, you said? X minus 1. All right, x minus 1. Let's double check. Let's double check to see if this is correct. Oh, it is correct. Very nice. Yeah, I guess there's nothing to check. I don't know why I said I had to double check. Yeah, so one way to double check is you can take this thing and do the derivative. Derivative of natural log is 1 over that. So it's good, yeah. Don't forget the plus c. So let's do a plus c here. Very nice. Okay, so let's get rid of that and see if we can work with this. So let's do the same thing. You're going to find the series representation for the thing that's inside the integral. It's not all that hard. In fact, I hope you can do it in your heads, but if you can't, I can help you with it. So see if you can figure out the, oh, and I mean, well, let's see. Let's see if you can do it. All right, Ben H., welcome back. You got something? Okay, but you do know this one. Just a minute, Ben. You're gonna do this. It's not that hard. You know this one. What's that series representation? Yeah, x to the n. Perfect. So that's what that is. All I want And so you've done a great job, Ben. So I'll pick someone else, not to worry. Unless you want to fire it off here and do the one that I've got up here. You see the difference between those two? Yeah, just a negative. Very good. So yeah, so the difference is that the thing up there in the integral is the negative of the thing down here that you were all familiar with. So yeah, it's just going to be the negative of this summation. Nice work. Okay, now we need to do the actual antiderivative. Let's see, I'll just do that. Put that over there. Put this in a little thought bubble. So we love thinking about that, don't we? Okay, so so next is to do the antiderivative, and it is kind of hard to think about doing an antiderivative of a summation, but you can do this. Just do it one bit at a time. So Karen, what is the antiderivative of x to the n? So you're right, you got to do something to that n. So let's just remind you what that is, because I know you know the rule. If it was x to the 5th, what would you get, Karen? Yeah, and what did you do to go from 5 to 6? Oh, so you add 1. Very good. So we're going to add 1. Whoa. Get rid of that. Very nice. So add 1. Add 1 to that, that n, and then, of course, divide exactly what you said over here. We're just going to do the same thing over here. Very nice. And this is plus c. So that's pretty much it. Although it would be nice to make sure that we know what the c is. So let's go ahead and copy this down. The natural log of x minus 1 is equal to the negative of this, and we'll do the limits, what is it called? The interval as well. So I need to know what that constant, what the constant of integration is. Oh, did I do bad? I may have done something bad here. Oh, I did. Yeah, this is no good. Sorry, I think I should have done x plus 1. Yeah. Okay, let's change up. Sorry, I mean let's see, can we do anything with this? I guess my concern is that if we plug 0 in here for x, the natural log of -1 is undefined. That's my problem that I'm having. Yeah, I think I blew it. I should have either thrown an absolute value in here or something. Yeah, I don't think this converges anywhere because natural log of -1 is undefined. So, yeah. Yeah, I don't like this. Yeah, I think I chose poorly. Let's just change it up just a sec. So just do this. Here, I'll even do this in a different color. Make this x plus 1. I think that's what I should have done. I was thinking that we need to shift over the natural log a little bit. I shifted it the wrong direction. So I apologize. So anyway, yeah, do an x plus 1 here. And what that's going to do is that's going to change. So we've got this in our brains. But if you put a plus 1 here, what that actually does is it changes this to -1 to the n. I mean, think about what that would mean. If you have an x plus a 1 plus x, you would have to do 1 minus -x. And so that's where the -1 would come from. So yeah, this is going to be better. Maybe I should just hang it up for the day. But let's see if we can salvage this. So this will be -1 to the n. And this is no longer going to be a negative. Okay, yeah, this makes much more sense. -1 to the n, and get rid of the negative. Okay, so you can see in pink the things that I've fixed. This is such a cool series that I gotta fix it. So this is going to be x plus 1, and this is -1 to the n, and this is going to be positive. Okay, that's much better. Now it all makes sense because now you can actually plug in x equals 0 and have it be something that actually works. So to figure out what the c is, we're going to do natural log of 0 plus 1 is going to be this sum, negative 1 to the n, 0 to the n plus 1 over n. Is that the buzzer for us to leave? Oh, no, we got a few minutes. Must be someone's got an appointment in a few minutes. So we'll get out of here, don't worry. And so that gives you c equals 0. Yeah, this is much better. Natural log of x plus 1 is negative 1 to the n over n plus 1. Sorry, there's a summation here. X to the n plus 1. Yeah, so this is another one of my favorite series. Oh, and the limits here. This is going to be between 0 and 2. Yeah, I should have probably written this out. X plus 1 has to be between 1 and negative 1. Wait a minute, subtract 1 from, wait, did I blow it again? Hold on a minute. Oh, it's because, yeah, what I'm doing, I guess here's where I blew it. Here, let me fix this. So this is, r is negative x. There it is. So r is negative x. And so negative x is between 1 and negative 1, which means x is between 1 and negative 1. That's better. Okay. Now, since we just did an antiderivative, we would want to check. And if you checked the limits, you would find that when x equals 1, so if you check the two endpoints, you'd find that when x equals 1, this is okay. And, because of the alternating series situation. So that's the thing. But it's just a kind of a cool expression for natural log. So x plus 1 is negative 1. Let's see, when n equals 0, so over 1. Oh, that's going to be positive 1 over 1. So you start with 1, and then you subtract off, oh, that's times x. Sorry, get it straight. So you start with x, then minus 1 over 2 x squared plus 1 over 3x cubed minus 1 over 4x to the 4th, and so on. So this is just kind of an interesting expression for natural log, that natural log equals this. So I just kind of I like it when things work out nicely with this. Okay, so hopefully you can do the homework. Just do your best to do integrals, derivatives. Just a few more power series. We'll do Taylor series tomorrow. I know you're excited to see where this all goes. I'm going to stop the recording if you want to come check.